Welcome back, everybody. This is going to be part 1 of 6 in my lecture video series on graphing functions by transformations. Let's get started. In this video, we're going to talk about parent functions specifically. This is going to be the starting point for this whole process of graphing by transformations. And unfortunately, it has a bit of memorization involved to help make the rest of graphing by transform. I'm just going to start that over. In this video, we're going to graph. We're going to start out by looking at a class of functions called our parent functions. These are going to be starting points for all the stuff we're going to learn in the later videos in this series. For now, I've got 7 types of functions that you should know how to plot the graph of. One of those is a constant function. Those look like y equals c, for example. This is the set of all points that have a y value of c. So for example, let's just suppose that's 2 for right now. This is one example. Well, all of the points with y value 2 are going to be on that horizontal line. So sure enough, constant functions just look like horizontal lines. And that horizontal line is going to be wherever the value of that constant is on the y-axis. Another parent function that we've already talked about how to graph are linear functions, the ones that look like y equals x. This is just going to be a diagonal line through the origin with slope 1. Oops, let me use a color there. That's a linear function. The next one we're going to take a look at is the absolute value function. Now remember, really under the hood, that absolute value function is a piecewise defined function. It's x if x is positive, or negative x otherwise. So when I'm looking to the left of the y-axis, that's when x is negative, I'm going to have the line that passes through the origin with slope -1, and my ruler here isn't working. There we go. So I'm going to have this guy just up until 0. And then at 0, I'm going to switch over to this guy that I have graphed here, y equals x. And so the absolute value function gives me this V shape. Moving on. The quadratic, which I have misspelled here, a quadratic, and we're going to spend more time on these guys a little bit later, has sort of this U shape here, and the easiest quadratic to graph is y equals x squared, and it sort of looks like a U, but we have a fancy name for this shape. It is called a parabola. More on that later in the class. But that's a parabola. The square root function looks like this. And the simplest one to graph would be y equals root x. And you can imagine if a square and a square root are important, a cube and a cube root are important as well. The graph of y equals x cubed almost matches the parabola on the right side, but then it gets bent around on the other side, and it looks like that. Similarly, for a cube root function, y equals the cubed root of x being the simplest one to graph, I get something that looks like this. Oh, hang on. It was horrible. There we go. Much better. So These 7, and I'm zooming out here, so if you'd like to pause and take a picture of this or something like that, you're welcome to. These 7 graphs are going to be very important moving forward, and I do expect you to have them memorized. That's going to wrap it up for this video. There's a bit of information dump required to get started here, and I just wanted to get all of that out of the way in one video. In the next video, we're going to look at the simplest transformation we could do, which is called a translation. Catch y'all on the next one.